In today's lab, you performed two single replacement labs where you first took magnesium, which was a metal, so you should know its state of matter, and you reacted it with a solution of hydrochloric acid. So remember, that's dissolved in water. It's not a liquid, it's a solution, so it's aqueous. And you saw that you formed a couple of different products. One product that you formed you knew was a gas because you saw bubbles, and of course that's going to be in your observations. When you did your splint test on this, you found that should have found that this did a pop. So when you have a pop, you can tell that that must have been hydrogen gas, and hydrogen, remember, is written as H2 because it's diatomic. It's part of phenolphthalebriate. Even just looking at these two, HCl and Mg, if you had to make a gas, it makes sense that hydrogen would be the gas because you could see it in here. Now, just for the record, chlorine happens to also be a gas, which is a poisonous gas, so we would not have done that in this lab. All right, so hydrogen is all by itself. You could see what happens, that Mg is still here and Cl is still here. Now you have to figure out how they go together. So you look at your periodic table, you understand the charges, that Mg is a +2, Cl is a -1. So of course you're going to make the formula as MgCl2. Now, you didn't see any solid MgCl2. This is an ionic. It would be a solid if it were by itself, but since it's in water, it's aqueous, it's dissolved in water, and that makes sense because you know your solubility rules. And you know for chlorine, right here, that brickles trickle except for the happy tickle. So because chlorine is brickle and Mg is not part of the happy tickle, this will be aqueous. So then you know your last step here is going to be to balance this with coefficients. And you should have also felt the relative temperature and found out that this felt hot. If it feels hot, that means heat is being released. And this is an exothermic reaction as well. So don't forget to record your observations. Now the next one, you took a piece of aluminum foil. So again, you should know the state of matter for foil. And you again reacted this with a solution of CuCl2. It's a solution, not a liquid, because it's dissolved in water, a salt dissolved in water, so this would be aqueous right here. And again, you saw a single replacement reaction occur, but this time it was not a gas that was formed, it was a solid. And the solid that you saw had a brownish color to it, which should remind you of the color of copper when it is a solid, like in a penny. So copper solid was formed, and then looking at the equation, you could see what's left is the aluminum and the chlorine. But you have to figure out what charges these are to figure out the formula. So you know Al is a +3 from the periodic table. You know chlorine, which is really chloride here, is a -1 because it's chloride because it's an ion. And so you know you're going to need 3 chlorides to go with the aluminum. And let's think about what we saw at the end. There was no solid aluminum chloride salt. The only solid you saw was the Cu. And you should understand that that makes sense because, again, we know that chlorides are soluble, brickles trickle, except for the happy tickle, and Al is not the happy tickle. It's Ag, which is silver, is the happy tickle. So this would be aqueous right here, and then you have a solid for the copper. And again, you're going to fill in your coefficients for balancing this equation. And you should have also felt a little bit of a heat given off in this reaction. It was not as obvious probably as the one before it, but it was definitely slightly exothermic, so you should have heat written there. And of course, don't forget to write down your observations. Included in your observations, you could have realized, if you were really paying attention, that this solution was blue, and that's due to the copper ion, the +2. This copper is a +2. You could figure that out because the chloride, you know, is a -1. So the copper 2 is giving the blue. Copper 2 is blue. You should have noticed that this copper color was going down. The blue was going down. And the reason why it was going down is because it was getting less of the ions and more of the copper metal, solid. Aluminum ion does not have a charge, so it's colorless in solution. So all you should have noticed with the solution is that the blue is decreasing, and you should have noticed this brownish, orangish solid forming, and the aluminum was going to be disappearing, of course, because it was turning into an aqueous ion, so you saw less of the aluminum. The same thing happened with the Mg. The metal disappeared. The The reason why it disappeared is because it turned into an ion, which was dissolved in water. And so you saw no more solids in this one because all this is aqueous. There's no solids in the products. Whereas here you did see a solid because there was a solid in the product.